Welcome to this video on solving systems of equations. This is College Algebra Math 1111, General Skill number 6. And if you're using the Blitzer text, you will find this information in section 8.1 and 8.2. So we're going to start with an introduction about solving systems of equations, what exactly is a system, and then deciding whether or not an ordered pair is the solution of a linear system. So let's start there. Hey, is an ordered pair a solution to a system? Well, what the heck is a system? Okay, so a system of equations is a set of two or more equations in two or more variables. And we are going to start by talking about a system of linear equations. And so it helps to know that the graph of any linear equation is a line. So if you're talking about the set of two lines, which is the smallest system of equations we can have, we would think about how two lines interact in one of three ways. The very first one is the most obvious one. If you have two lines that intersect, at some point on the plane, you will see that they intersect in a single point. Now, one thing you can say about those two lines is their slopes are different. If their slopes are different at all, they will intersect at some point. Now, a solution to a system of equations is a point that the two lines share. So if you're looking at this graph, you will see that those two lines share exactly one point where they intersect. So they have one solution. The system has one solution. And we classify this type of system as a consistent, independent system. Now, another way that two lines might interact is they could be parallel. So if the lines are parallel, their slopes are the same, but their intercepts are different. Notice they have the same rise and run, but where they intersect, the y-axis and the x-axis will be different. Now, in this case, how many points do those two lines share? It should be fairly obvious that they don't ever intersect, and so there will not be any solutions to this system. And we call this system an inconsistent system. And then the last way that two lines can interact is if they coincide, okay? And so it is often said that lines coincide when one lies right on top of the other. So their slopes are the same, their intercepts are the same, and yes, you would be graphing the same line twice if you were to graph the equations of these types of lines. And in this case, how many points do those lines share? Well, every single point on those lines is shared, and so there's an infinite number of solutions. And we call this type of system a consistent, dependent system of equations. So then, now we know what a system of equations is. We are going to think about then, oh, my graph on the right has gotten messed up a little bit, and we're just going to pretend like those lines are coinciding still. But we want to know what to do to figure out if an ordered pair is a solution to a system. So the solution to a system of linear equations is a point that has coordinates that satisfy both or all of the equations in the system. Right now we're just talking about a system of two equations in two variables, but we will progress into systems that are a little more complicated. So we want to find a coordinate that satisfies all the equations in the system. And so to check if a coordinate is a solution to a given system, we're going to substitute that coordinate in to each equation and make sure that it satisfies the equations that make up the system. So here's an example. We are given a system of equations. You see this system right here. It's this set of two equations in two variables, and we want to determine if the ordered pairs -2, 0 and 1, 2 are solutions to the system. So we want to substitute the first of the ordered pairs into both equations and see that it satisfies both equations. So let's try in the first equation. If I sub -2 in for the x and the 0 in for the y, we want to know if what is calculated here is equal to the right-hand side of the equation, -4. So when we do this calculation, we would have 2 times -2 is -4 minus 0, which is -4. So since -4 is indeed equal to -4, this coordinate works in this first equation. But we're not done yet because we want to see if it's a solution to the system, not just one equation. So we need to go ahead and substitute that into the second equation. Okay, so we're going to sub in the -2 for this x and the 0 in for this y. And that kind of looks like this here. And again, if we do this calculation on the left-hand side, 2 times -2, which is -4 plus 0 is still -4. Yes, -4 is equal to -4, so yay, -2, 0 is a solution. So we've dealt with -2, 0. Now we want to check 1, 2. So let's check 1, 2. By doing the same thing. Let's substitute 1, 2 into both of the equations. We'll start with the first one. We'll put the 1 in for the x and the 2 in for the y. And we want to check, is 2 times 1 minus 3 times 2, is it equal to -4? And we know that 2 minus 6 is indeed -4, so yay, that works. And then the last check is we need to take that 1, 2 and sub it into the bottom equation. So we'll try that. 2 times 1 plus 2, is that equal to -4? Well, 2 plus 2 is equal to 4 and not -4. So since these are not equal, this is not a solution to the system. All right, we will move into the second video, which talks about solving a system of linear equations by substitution. That's the second task in this skill set. All right, see you there.